Hi there and welcome to BeIndie.biz. My name is Alan Thorn and I'm a game developer with over 20 years experience, and I love helping people make games using interesting tools, and they don't get much more interesting than the Godot engine. In this tutorial we're going to be looking at the lesser known data type of curves. We're going to see the awesome power of curves and just how much we can do with them using pretty simple pieces of code. Take a look at the Godot engine right here inside the editor. You can see that we have a project running. We have this kind of caravan scene, and we're using curves to create a smooth, repetitive motion on the camera, moving on the X and the Y axis in a kind of repeated, throbbing motion to create gentle camera movement that can make the scene come alive. Now, to achieve this, we're not using pre-made animations, we're using curves. If you take a look at the object inspector here, you can see one of the great things about curves. We can actually draw a curve out inside the inspector, and then we can evaluate that curve inside our code. This allows us to create value ranges. We can make sure that particular values are locked between particular ranges. We can blend numerical values. We can animate those values over time to create motion. Curves are really useful if you want to create smooth motion on your cameras, as we're doing here, but it's not just restricted to cameras. We can create moving objects that need to follow paths. We can create throbbing lights. We can change timers, all kinds of stuff here. So we're going to be taking a look in this tutorial how to get started at creating this scene using curves and the C# scripting language. So let's get started. So in this tutorial, we're going to see how to harness the awesome power of curves using the C# scripting language. To get started, I'm going to use this scene that you can see in front of you here. Basically, this is an empty Godot scene in which I've imported a model from Sketchfab. That is all there is to it. Now, the model that I've imported into this scene here is this low poly 3D caravan aesthetic. Now, I downloaded this here on Sketchfab from the link that you can see included here in the Chrome browser window. If I scroll down, you can see that this was a model produced by Captain Low Poly. You can download this completely free of charge and import that directly into the Godot engine. Now, although I'm using this model, you don't have to use this model. You can use absolutely any scene, because the code we're going to be creating will work on camera objects, and it really doesn't matter what scene you're using. It will work with any scene. The complete script file we're going to be creating in C# will be available for download at the link provided in the description of this video. I'm going to minimize Chrome here and go back to the Godot engine, back to our scene. Now, the very first thing that I want to make sure that we're going to be doing is getting the camera set up. We're going to be working with the scene camera that you can see here. We're going to be animating that gently on the X and the Y axis repeatedly over time using curves. So to start with the camera, I'm going to position my scene view at a position where I think the camera ought to be, so maybe somewhere around there. I'm going to select the camera object, move to the perspective section, and then choose Align with View to frame that shot here. I'm pretty happy with the camera being located at this position here. If I want to check out the kind of view we're going to get from the camera, I can click the preview button to take a look at that here. And that's pretty good. I might move to the camera settings and tweak the field of view just a little bit. I'm going to change that to 70, and that's looking absolutely fine. I'm going to close out the camera preview here and then use Command S or Control S to save my scene. Now, the next thing we want to do is we want to customize the behavior of this camera using curves. To do that, I'm going to select the camera and in the inspector, scroll all the way down to the bottom to the script field. I'm going to click on the drop down and choose New Script to add a new script. We could alternatively use the Script tab here, but I'm going to create a script from this section here. Now, in this part, we need to be very careful about the scripting language we are going to be using. In this tutorial, I'm going to be using C#. Throughout the BeIndie.biz channel, we're going to be using either the C# scripting language or the visual scripting languages. So I'm going to select C# here. That is a very common language used throughout game development. Most notably right now, it's also used in the Unity engine. Now I'm going to be inheriting from the camera class here because I'm going to be customizing the behavior of our camera, and inside the path I'm simply going to call the script file we're going to be creating here. I'm going to call that cam translate and then choose create to add that script file. This will then present us with the scripting editor. We can easily get back to the 3D view by clicking on the 3D button and then switching back and forth. Now, one of the things that this does here is if I press the tab key, it will insert tabs, visible tabs, into the file. Now, I really don't want that. I want to hide these tabs. So to do that, it's really easy. I'm going to move to the editor, choose editor, editor settings, move down to the text editor part, and then the indent part. For the draw tabs field, I'm going to deactivate the on checkbox and choose close. When I do this now and I use the tab key, it will leave the tabs invisible, which is what I want. I don't really want those showing up inside my code. So now if I select the camera inside the viewport, I can move down to the bottom right hand side of the inspector. I will see that my cam translate script has been added to the camera here, and here inside the file system I can also see my camtranslate.cs, which is my script file. Now I can create a new folder to house my script files, but in the case of this tutorial we're creating just one script, so I'm going to leave that exactly where it is. So now we're going to customize the behavior of our camera using curves. These are an amazing feature. To do that, I'm going to switch back to the script view, and we're ready to get started on our script file. Now, step number one in working with curves is we actually need to create the curves themselves. We're going to be using curves to instruct Godot how to move between different values and to interpolate between values over time to change the position of our camera. To create the curves and to make them interactive so that we can adjust them visually in the inspector, we need to expose those variables. It's really easy to do. I'm going to move to the top of the script file here to the variable declaration section. Now, it's left some comments here to show me where I should put them, so I'm going to delete those comments. We don't really need those. I'm going to begin with the export attribute in C#. This is going to make our variables show up inside the inspector. If you're from the Unity engine, you'll be familiar with using the public keyword to make variables display in the inspector. That's not how it works in Godot. Even if you use a public keyword, it won't necessarily show up. You have to use this export attribute to make sure your variable displays in the inspector. So I'm going to use the export here, and I'm going to create our first curve. So I'm going to use the curve data type. This is going to be our X curve. This is going to define the motion of the camera on the X axis. I'm going to repeat this process here, once for the X curve here, and then for the Y curve. So I'm going to add Y into there and save our code. Now, when I go back to the camera inside the 3D scene and I select the camera, nothing initially shows up. But if I press the build button to recompile the C# code, when that compilation completes, we're going to get a very different display here inside the camera view. You can now see we have script variables, we have an X curve, and we have a Y curve. Now these values begin completely empty. The curves are actually a separate kind of asset, so we need to create these separately. Really easy to do. We just move to the X curve, click on the empty drop down and choose new curve. I'm going to do the same for the Y field. Pretty easy. You can now see we've got two completely empty graphs. Now I'm going to come back to these graphs in just a moment to tweak their values, but I've just created them here. So let's go back to our script file. Now the next thing that we want to do in evaluating these curves is we need to be able to read values on the x-axis. The x-axis is going to represent time. So for example, let's say that the camera motion to do one complete loop is going to take 2 seconds. So that means that on the left-hand side, we have 0, and on the right-hand side, we would have 2. And similarly, on the section here, we would have other values for the vertical axis, and that tells us what the position of the camera should be on the x-axis. So I'm going to go back to our script file here, and I'm going to define a speed value. This is going to effectively tell Godot how quickly we should move through the x-axis to read values from the y. So I'm going to create an export field here, and we're going to make that a public float speed, and by default the speed is going to be 1. That would mean it's going to move 1 unit across the x-axis every second. Now I'm going to be keeping track also of 2 private variables. These are going to be my x curve, x value, which is going to start at 0, and we're going to have 1 for the y value. This is going to be, over time, we're going to be moving through the graph, beginning at 0 and ending at whatever the maximum is. This is going to keep track of that x value accumulating over time for each of our 2 graphs. So that's the x value of that graph. Perfect. The next thing, and in fact the last piece of data that I want to keep track of, is the starting position of the camera. When the level begins, we want to keep track of where the camera begins so that we can move and displace the camera away from that center. So that's going to be a vector variable, vector3, and I'll call this start pos, and it's going to equal initially vector3 dot 0. It's not required that we have to provide that starting value, but I kind of like to do that in any case. But in the start function, this ready function here, which happens when the level begins, in this function we're going to record the start position. So that's going to equal transform dot origin. I'm going to save that code here. That is, it's going to take the position of the camera in the scene and store a copy of that inside the start pos field. Now the next thing I'm going to be using is the process function, which is going to happen every single frame or every single step. We need to activate that function so that we can update the motion of the camera over time. So I'm going to remove the comments for this function to bring that into play. And at the very beginning of the function, I'm going to create a local copy of the transform for the camera so that I can manipulate it. And then at the end of the function, I'm going to write that back. So that between these 2 statements here, I'm effectively going to be adjusting the transform of our object. So the first thing that I want to do here is I want to determine what the value is from these different curves. So let's take an example. Let's take the x curve up here. I'm going to grab the x curve and I'm going to use the function interpolate, like so. And for the interpolate function, here is where you provide a value on the x-axis. So if I want to read from the graph on the left-hand side, I would put in the value of 0. If I were to try to read the value on the right-hand side, by default the maximum is 1, so I would put a value of 1. And it will give me back the y value. We can quickly check that by trying to print the value that we get back. For example, here is the x curve value. And I'm going to plus equals delta over time. So it's going to continually accumulate over time. And I'm going to plug that in as my x value and do gd.print to print that to the console. I'm going to save the code here and recompile that. And we'll take a look at what that gives us inside the console when we press play. So let's go back to our 3D scene here, and I'm going to open up the output so I can see the values being printed. I'm going to press play on the toolbar, and this gives us back, well, continually a value of 0. And the reason for that is because when we take a look at the x value here, you can see we have no points and every value is always 0. So what I'm going to do is I'm going to start to add points on my x curve. So I just clicked on the graph here to open up the display. I'm going to right click and choose add point to add 1 point to the graph and put that back down here at 0. I'm going to right click and add another point, and I'm going to move that up to about the middle here, and then again bring that back down to 0. So we've got this kind of bell-shaped curve. going to accept those changes here, and you can see already the curve is then projected into the view. If I now press play, in fact I'm going to save my scene first and choose play, we're going to get very different values printed to the console. And now you can see it's reading off those values. Now it continues to move to 0 afterwards, and the reason for that is because when I go back to my script file and we're continually incrementing on the x-axis here, it eventually goes beyond 1 on the graph, at which point the values have become 0. We actually want to restrict the reading of these values to the x-axis within our range here. So effectively what we want to do is, if the timer continually pushes the x value beyond 1, we want to wrap back around to 0 again, and we're going to see how to do that in just a second. So when we come to calculate the x value for our curve here, what we effectively want to do is we want to use mathf.wrap. The wrap function is going to keep our values within the range. So for example, if we specify the range of 0 to 1, it's going to keep our values within 0 to 1. If we were to enter a value like 1.5, it would wrap it back around to 0 and choose 0.5 in a complete loop. So the first argument for this wrap function is going to be the value that we actually want to put in. So the value is going to be our x curve value, plus we're going to have our delta. In fact, I beg your pardon, it's going to be multiplied by our delta, multiplied by our speed, which is this value here. That's going to be the value we'll use for our x curve. Now the range, the final two arguments of the wrap function are the range, the minimum and the maximum. And you know, it really is quite convenient, because when you take a look at the curve here, we can specify what our minimum and maximum values are, and we can retrieve these values in code. So for the x curve, it's going to be dot get min value, like so. And for the max value, it's going to be get max value. And that is going to complete the wrap for the x-axis. And this time, if I now press play on the toolbar and read off the values from the console, we're going to get quite a different output. Now you can see these curves moving through here. In fact, actually it's keeping between the minimum and the maximum. That's fine. I'm going to choose stop a second. Okay, so when we take a look at this, we're getting actually a complete readout of 0. That's not what I was expecting. I was expecting the function to wrap around on the axis here. And the reason for that is simply because of this multiplication symbol here. It should actually be the x value plus delta times speed. I'm going to resave that and then choose play again. And finally, this time when I press play and we go back into the level, we're getting this complete readout on the x-axis. You can see that this is continually looping and it's going back and forth across the x-axis, and now we're getting complete loopable values that are working out. So I'm just going to close back, play back here. I'm going to take this line, which basically is working fine for the x-axis, and really we're going to be repeating this for the y-axis here. So I'm going to grab this for the y-axis, the y curve get minimum and the y curve get maximum. I'm going to save that. Now, of course, we haven't actually defined what our x curve or our y curve is here. We've defined the x, but we've not really done the same thing for y. So I'm going to click in y and do a similar thing, add a point to the middle, drag that up, drag that down to the right hand side. So now effectively we defined two curves. In this case, they're pretty much identical curves, but that's okay. They could be completely different if we wanted them to be. Going to grab these two curves here. We've got these in place. And then the next thing that really we want to do is we want to interpolate these two curves to adjust the position of the camera. So I no longer want my print statement to the console. This is really easy to do here. All we need to do is to say transform dot origin. Remember, origin is my position. It should equal my start position plus, and in this case it's a completely new vector 3 where we're going to be adjusting our position. So the position on the x-axis basically is going to be our x curve dot interpolate, and effectively we're going to be interpolating based on our x curve. And then the second parameter is going to be our y curve. That's for the y value here. And the z value, well, we're going to leave that unchanged. So we have these two values, x and y, being changed for the camera. I'm going to clear the console here, save my complete code. I'm going to go and compile those changes to make sure that they're working as intended. I'm going to go back to my scene here to take a look at the camera, press play on the toolbar, and let's see what happens here when we play this inside the editor. You can see that actually this is looking pretty nice here. I think that one of the main problems that we're seeing with this scene, you can see that it's adjusting the position of the camera. That's great, but I think it's moving a little bit too fast. And so we can come back here, go back to our camera, and I'm going to go to the speed variable, and I might change that to 0.3. And let's see how 0.3 works out for our camera here. Yeah, that's looking much, much better. We're now getting these two curves in place to change the position of the camera. And now that I've changed and adjusted the speed, reduced that, we're getting a much smoother, more gentle motion for this camera here, interpolating between these two values. We're getting interesting animation just based on two curves. And all we really did was create a few lines of C# script. So what this shows us is that curves are a really great way to interactively draw out curves directly in the inspector. And we can evaluate those curves here in code to affect the movement of our objects. The potential for this is limitless. If you need to create a space shooter with enemy crafts that move up and down along curved trajectories, you can use curves to plan out the motion of those objects. You can tweak the field of view of the camera. You can change the colors of lights using this thing. They really are incredible. Make sure that curves become your friend, and you'll find that your power to create interesting games and animations will increase exponentially. So I hope you found this tutorial helpful. Please remember you can download the full source code following the link below. I've been Alan Thorn. This has been BeIndie.biz. Stay tuned for plenty more tutorials. I'll see you next time.